Purpose: to show in clear, concise, and direct way the highlights of the technology and best practices used to guarantee the complement of customer requirements. Company profile: ever since its foundation in 1974, our operations have expanded through several production sites in Asia and overseas. Overseas, Kyungshin has facilities in the United States at Montgomery, Alabama, and West Point, Georgia. The first Kyungshin production facility was opened in San Pedro Sula, Honduras in 2003. In 2009, our operations were expanded to Mexico, opening the second manufacturing plant at Durango. Lately, a new satellite plant was opened in the same state, in Nombre de Dios community. The most recent facility was opened in Ciudad Juárez, Chihuahua in 2013. The HIS and MES. Our company capabilities are enhanced by the use of in-house software developed through the years to cover the corporate organization needs to process manufacturing data and produce harnesses. HIS. The Harnesses Information Support System was developed in 2007 as a global database to process the design information provided by customers to obtain bill of material, circuits cut sheets, visual aids for processes, labor calculations, and others. MES. Alongside the HIS, our in-house management execution system allows to synchronize in real time the production activity to track inventory for traceability at each area in the process. Warehouse. In the receiving area, the incoming material is scanned to match the invoice data from supplier and assure the inventory accuracy to later be allocated in the warehouse. The system, which is linked with the MES through the scanners, allows to track the material as it is moved from the receiving area to the whip. Cutting. In the cutting area, the circuits are cut through the information contained in the process sheet, which provide the materials and technical data for the circuits, wire, terminals, seals, and applicators. The machine setup is pro-caillot to prevent a wrong component to be used. To start production, the process sheet needs to be scanned. The material and tooling requirements are displayed on the screen. The operator needs to scan each material part number. The software then compares the data, assuring that the correct material is placed before cutting circuits. Each machine is equipped with crimping force monitoring system to detect crimping issues such as low and high insulations, wrong strips, wrong components, and others. The machine automatically cuts the circuits in case of any issue detected, are protected against mechanical damage and contamination using plastic caps. Secondary processes. The semi-automatic crimping machines are equipped with CFMS system and a smart chopper to assure that every defect detected by the CFM is cut before the press can crimp again. All the cut samples fall into a locked scrap box. Our plants are equipped with the tooling and machinery needed to process twist pairs, metal strip, and crimping splices, ultrasonic, shielding, and others. Final assembly. One set supply. The component area is based on just-in-time philosophy. The material is supplied to the assembly line only according to what is needed, when it's needed, and in the amount needed. The components are provided to the assembly boards in trays that contain the specific amount of material for each harness's part number. Through this method, the web inventory is reduced, and the handling of material in assembly board as well. Also, helps to the operator to easily identify any missing components of a harness. Sub-assembly. The sub-assembly area consists of the stationary workstations where circuits, connectors, and additional components are assembled under a controlled environment. The purpose of the sub-assembly is to reduce the circuit's insertion in a rotary. Activity is more difficult to learn, to control, and with much variation and performed in sub-assembly as a matter of fact. The design intends to assign in sub-assembly at least 80% of insertions. The BB fixture is used to assure the operator follows push, click, pull method. Circuits protection is a priority. All the subassembly lines are equipped with protector canvas to prevent terminals and circuits damage. Assembly board. The most critical part of an assembly board is a well-designed layout. The HIS provides a powerful tool called HIFOM. HIFOM stands for Harness Information for Form Board. It is a visual CAD tool to create harness layout, simulating the harness design over an assembly board surface. The HIFOM design is based on customer blueprint requirements, ergonomics, components design, and 3D considerations to prevent installation issues at customer assembly line. The assembly boards are built using the proper tooling to route circuits, apply coverings, and fix components. Protector table. That protectors and its additional components are installed in the harness as is required in the blueprint, 3D views, and installation diagram. Dimensional board. The dimensional board is used to ensure that harness dimensions are according to blueprint and within tolerance. It also serves to detect the presence of clips, protectors, grommets, connectors, and other additional components. Wire harness and offline test. The electrical test board is the workstation where operators plug in the harness in electrical models to perform tests such as continuity, vacuum, air leak monitor, and other component-specific checks. Electrical test models, also known as electrical checker fixtures, are built according to in-house specifications to prevent design issues from suppliers. Our specifications provide details about the pogo pin size, contact point, and polka yokes to detect all failure modes identified in the PFMEA control plan. Fuse and relay. In this workstation, fuses and relays are installed preventing quality issues such as missing, not fully seated, damaged, broken, extra, or wrong components. Torque. The torque workstation consists of the following key elements: torque screwdriver, socket nut, torque arm, torque controller, ERJB fixture, and other tooling and equipment installed in the table to assure that the torque value is applied as required by customer. The workstation is error-proof and is equipped with these features. Bottom cover. This workstation is designed to install the engine room junction block bottom cover, assuring its dimensions to the nearest fixed points, and considering any 3D installation restriction. Vision. Vision system has two main purposes: detect missing, extra, or misplaced components in fuse box, to perform a continuous electrical test of fuses and relays. The vision system is equipped of a smart camera, image sensor, lens, lining PC, or programmable logic controller (PLC), image processing software, connection cables, and mounting hardware. Final inspection. The final inspection station involves examination, testing, gouging, measuring, and comparison of each harness against a master sample. The inspection determines if the product accomplished the customer specifications. The workstation is equipped with cameras to detect bent terminals, fixtures to inspect critical dimensions, and others. Packing and shipping. Packing and shipment designed to make the final hanging of the harness, to scan the product label, and accommodate the harness into the shipping container per the packing specification. Since its foundation in 1974 as the first vehicle wiring company of South Korea, Kyungshin has taken a long path along with the domestic vehicle industry, with consistent investment on innovation and R&D. We are ready to face our customer demand with highest world-class quality standards, with a flexible manufacturing process and fast response capacity to customer changes. We can guarantee the excellence in our products and services.